Sonio is a machine learning software designed to guide practitioners through the differential diagnosis of prenatal syndromes. Now indeed, there are more than 300 such syndromes, 600 potential anomalies that can be detected by fetal ultrasound, and theoretically, 3 to the power of 600 different possible combinations of such sonographic anomalies, considering that each sign may be either present, absent, or considered uncertain by the practitioner. This extreme complexity is not tractable by a single physician. For example, a non-specialized OBGYN might be able to remember 3 to 10 prenatal syndromes and have them readily available in his mind during ultrasound examinations. An expert physician, an MFM specialist, or an OB with large experience in second-line ultrasound or with genetic background might have up to 30 syndromes on the tip of his fingers. Sonio allows the physician to tackle the whole complexity of prenatal diagnosis by providing a real-time diagnostic assistant that guides the practitioner during ultrasound examinations. Now, Sonio is not a software for image quality, nor is it a software for automatic recognition of fetal anomalies on ultrasound. Sonio is a diagnostic assistant that points in the right direction to optimize the path towards a diagnosis or to rule it out. This software is composed of an algorithm, a database, and an interface. The algorithm in itself is composed of 2 patented algorithms specifically designed for our tool. The first is a decision tree that finds the best next sign to look for at any step of the ultrasound examination. The second algorithm is a Bayesian network that computes the most probable diagnosis in real time at each step. The database is based on the Orphanet database and the human phenotype ontology, which we entirely tailored for fetal ultrasound, and which we augmented with external experts and existing literature. The interface was designed to take into account the ergonomics of each practitioner's habits. We can set the software to follow a predefined sequence of anatomical regions or to let the software take over, to limit the number of questions. We also added the option to add a sign at any time during the examination should an additional anomaly be discovered fortuitously. Now here's an example of how this software can be used. We set the software to English and set the mode to optimized by zone, which lets Sonio override our predefined sequence of anatomical regions. Now consider a mid-trimester ultrasound examination in a female fetus referred for a coarctation of the aorta. No invasive procedures has been performed and the nuchal translucency was considered normal. We type coarctation of the aorta and a first set of questions on cardiac anatomy pops up, to which we answer no to all. Now you might already have an echocardiography and therefore consider that the rest of the cardiac anatomy is normal. You can say so and go to the next anatomical region, and a new set of questions on kidney anatomy pops up, none of which we see during ultrasound. And again, we tell Sonio that we've seen all of the kidneys and wish to proceed to the next anatomical region. We answer no to the new set of fetal anomalies regarding general findings, a normal skull, no dysmorphic features, normal upper limbs. And here Sonio stops with a report popping up stating that the coarctation is likely to be isolated with a remaining small possibility of Turner syndrome. Now at this point, you may have second thoughts about the visualization of the kidneys, and you may consider a horseshoe kidney. Now, you may do so in the list of signs and say yes, which immediately changes the probability of syndromes, making Turner syndrome much more likely, along with other potential syndromes. Now let's take another example and start a new examination. Now consider a male fetus referred for a tetralogy of Fallot. Mother is 28. Restart examination. Type tetralogy of Fallot. And you may again tell Sonio that the rest of the cardiac anatomy is normal and that you immediately noticed a polyhydramnios. You do so by clicking on the plus sign and then the software asks about the ears, which we consider normal. Genitalia, also normal. However, when looking at the spine, we discover a supernumerary vertebra, the rest of the spine being strictly normal. And at this point, Sonio stops and concludes that bacterial association is very likely. Now we are currently using several approaches to validate our software. A first approach is to validate the diagnosis given by Sonio on random phenotypes of possible syndromic associations of sonographic signs generated directly by computer. Sonio performs very well in this setting when several signs of a syndrome are given. The correct diagnosis is accurately guessed within the top 5 most probable diagnoses in 90% of the cases. We also tested the robustness of our algorithm by gradually adding more atypical signs that are not part of the phenotype of the disease to be guessed. Again, Sonio performs very well. Even when 8 atypical signs are added, the correct diagnosis remains in Sonio's top 5 in more than 70% of the cases. The same approach was performed on real data, and instead of randomly generated phenotypes, we used post-mortem phenotypes following termination of pregnancy with a genetic confirmation of the diagnosis. On this data set of more than 80 cases, Sonio guessed the true diagnosis in 70% of the cases. He failed to identify the true diagnosis within his top 5 in only 9% of the cases. There are multiple aspects of the medical value of our diagnostic assistant. Of course, we aim to improve the early detection of fetal syndromes, most of which are associated with lifelong handicap. But we also believe such a device will help improve second-line tests, such as targeted genetic testing, or second-line imaging, such as MRI. A significant benefit of Sonio lies in the parental reassurance, in case of a fetal anomaly, even benign, by providing a standardized examination that rules out hundreds of genetic associations. These 3 claims concur to reduce the medical costs of prenatal diagnosis by limiting unnecessary repeated examinations, improve communication between care providers, and help optimize perinatal therapeutic care. The whole team thanks you for your attention, and we hope to meet you soon.